we'll move on.
Should we read this one?
This page? Yeah.
This page, yeah.
Right, so look on that page, find any questions you want to see, do go over.
74, please.
74.
Yeah.
Okay, so 74, 76. We'll start with those. If you have other questions, we'll do that. With almost all of these, so I'll say the first 1, 2, 3/4, your equation is going to be your y equals mx plus b, and you have to figure out which pieces are which, set up your equation, and solve for whatever is missing. But sometimes the setup is the same, but you're solving for different things. So in 74, if we know it's going to be a y equals mx plus b, your m is anything that says per or cost or gain. Your b would be anything that is like a one-time fee, a one-time charge, a deposit, something that you only do once, so like you only rent shoes once usually. Okay. And then your x would be your input, your y would be your output. So in this case, y, our output is usually our total. And then that means the 4 games would be our x, our input. How many games did we play times the cost plus the amount to rent the shoes would give us our total. Knowing all of that information, we could set up our y equals mx plus b with the numbers. So 30 equals our m, 695, our x, 4, and we don't know b. Then we could just solve for b. Multiply 695 and 4, so we get 27.8. And then get b by itself by subtracting 27.8 to the other side. What is our b value? Since we're looking for a one-time fee, this would be dollars. We have to label. Do you have any questions on how we set that up, solved it, got the answer? On the review, yes. Actually, I think there's 200 or something. But on the test, there's 1 for each objective. Did you hear what I said? Did you hear what I said?
There's, on the test, there's...
Like 200?
No, that's the
On the
review.
review. On the final, there's 1 question per objective.
Oh. Yeah, so. Right.
I'm like, they panicked before the sentence was even finished.
I was like,
wait till it's finished.
Like 200 questions, and I was just like,
it's just way to switch up.
There are like 200 questions on the review, yes.
And I did that backwards.
Count how many objectives. Like, count per page. Count how many pages you have.
Okay, so there's 9. This should be about
10 units,
10 minutes.
but multiple objectives.
So it's a bit like
Count how many pages you have. That would be weird.
Shoot. Alright, if I was doing the math,
But you guys can do that later. So 76, there are 2 different ways to do it. One in the calculator, one algebraically. Which would you rather, or do you want to see both?
Oh, please.
Okay. We'll do calculator first and then go back and do the other one. With this, our end goal is to write an equation. So eventually we're going to have a y equals mx plus b. But right now, we have numbers that depend on each other. This amount of square footage becomes this cost. So this is like an input and an output, and another input and output. We have x's and y's. But we don't have m or b. So if you think back to how we were doing the line of best fit stuff last class, in the calculator we're going to do that same thing. So reset your calculator first, second plus 712. And then we're going to go into stat, into edit, so 1 or enter. And you're going to put those x values in L1 and those y values in L2. So 850 and 1000 in L1. And 1172 and 1268 in L2. Then we're going to do the same steps that we did for line of best fit. So go back into stat, scroll over to calculate, so to the right, calculate, you're looking for linear regression, number 4, or down to 4, hit enter. And whether you store this or not is really up to you. I'm going to, so I can show you how to do it in the calculator. So go down to store regression equation, and then alpha trace, and enter 3 times. So this would be our line of best fit, our equation. Y equals 0.64x plus 628. Now we have our m, we have our b, where m would be the price per square footage, and our b would be like a one-time fee, or if there were no square footage, or maybe like a deposit. But then it asks us to find the monthly rent, so we're looking for y when x is 1200. So how you do this part is up to you. You could put 1200 in for x. And solve that in your calculator or by hand. And figure out what y is. So let's do that, and then we'll go back and I'll show you how to find it in the calculator. What is that total? What do we get when we put this either on the calculator or separately? Yes. 96.
96.
Okay. If you wanted to use your calculator, you could do one of two things. Either store 1200 for x, type in 1200, hit the STO button above on, and then hit X and enter. So that only put the X value in, we still have to have it solve it. So go back and grab your equation, alpha trace, and enter twice. So that would be one way. The other would be if you stored it to go into your table, second graph. Trying to get this back up. But if you go into second graph, you'll have to move it. Because it's like at 0. We need our x value to be 1200. Scrolling would take forever. So go into second window and change that start to 1200. And then go back to the table, second graph. You can do that any of those ways. Calculator wise. Questions about the calculator before we do it algebraically? If we were doing this algebraically, we would need to find our slope and find our y-intercept using different formulas. We're given x, y, so we would need to use y2 minus y1 over x2 minus x1 to find our slope of the 2 points. So let's say I make this 1 and this 2. Then I could use this formula and do 1268 minus 1,172 over 1,000 minus 850. And you could do that all at the same time, do it separately, and then simplify. Either or does not matter. I'm going to put this in all at the same time in the calculator. Alpha y equals to get the fraction. 0.68 minus 2. So if you put it in as a fraction, you would get out a fraction, 16 over 25. But if you wanted it to match what we already found, you could divide it. So you could write it as the fraction or the decimal, it does not matter. So 16 over 25 or 0.64, that's the slope that the calculator gave us, so that should match. Okay. But that's just one piece. If you're doing it algebraically, you found the slope, you still have to find the y-intercept. So then you're doing the y minus y1 equals m, and in parentheses, x minus x1. You're given 2 sets of points. You can use either or. I'm going to use the 1,000 and 1268. So y minus 1268 equals our slope. You can put in the fraction or the decimal, doesn't matter. And then x minus 1,000. Then you can start to solve. So distribute the 0.64 or the fraction. If you use the fraction, I would keep it in fraction form and just multiply. So y minus 1268 equals the fraction or the decimal x minus 640. Then we have to get it back in y equals mx plus b, so get rid of the 1268, add it to both sides. And when we add those together, we should get 620. So the doing it algebraically has more steps, but it still works as long as you do the math correctly. So if you forget how to do the calculator steps, you could do it algebraically, it just has more steps, and just remember that. If you remember how to do it in the calculator, then do that, because it would be easier. To find the final answer, the work would be the same. You would do it by putting x in, using the calculator, and equals. Okay, questions on that? Are there any others on this page we want to see, do, go over, have questions about? Bless you. Go on to the next one. So now we are in systems, and this one is systems by graphing. Which of these questions do we want to see, do, go over, and have questions about? So for 79, these are both in slope-intercept form already. So we're going to start at the y-intercept. So for the first one, start at -3 on the y-axis. Your slope is -1/1. So to go make it negative, I'll just write this as a side note, we can go up and left or down and right. And you may have to go both. So in this case, if we go up 1, left 1, plot a point every time you end up 1, left 1. And then and then do the opposite, down 1, right 1. And then once you have all of those points, connect them, draw arrows at the end. Then do the same thing for the other line. This one starts at +4 on the y-axis. The slope is positive. And if we want something to go positive or have positive directions, we can go up and to the right or down and to the left. So in this case, we can't go up 6, but we can go down 6. This is also over 1. So down 6 and to the left 1. And really, those are the only 2 points we can do on this. And then you would look for where did these 2 lines cross? And write that as an order. X and then 1. And that would be your final answer. Questions on that one? I'm going to start graphing 80, but we'll probably finish it when we get back. So if I start with this first one, I'm starting at -1. My slope is positive, so we can go up 3 to the right 2 as many times as possible, and down 3, left 2. Connect those points and draw arrows through it. The second line, start at +3. It has the same slope, so up 3, right 2, or down 3, left 2. I wanted to go off the page, maybe here, or off the graph. Draw a line, connect them, draw arrows through them. Do these ever cross? No. So this would be no solution. And we will do more when we get back. On this page.
Oh, can we do it with this? Hi.
Okay, for 81, we have to solve both of these equations, get them in slope intercept form. So move the 5x by subtracting, and do the same thing to the second one, move the x by subtracting. And do these x. So for the first one, we have negative y equals negative 5x minus 3. And the second one, you have y equals negative x. Second one is completely solved, but the first one we still have to get y by itself. So divide everything by negative 1, and we get 5x plus 3. And then graph them both. Starting the y-intercept 3, it's positive, so we can't go up 5, but we can go down 5. And to the left 1. And then for the other one, start at negative 3. The slope is negative, and it's negative 1 over 1, so up 1, left 1, as many times as possible. And down 1, right 1, as many times as possible. Look at where the two lines cross, and that would be your solution, your answer. At negative 1, negative 2. Other questions on this page? 79. I think the same thing. So on to the next page. Now we're doing systems by substitution. Find any of those you want to see. Do go over.
If we do number, you do number 86. And number 91. Wait, what?
Any others? So let's start with 86. The goal for substitution, we are taking one of the equations and putting it into the other. So if you have something that's already solved, so this one has a y equals, you can take that expression and put it into the other equation where y is. So let's rewrite it. Negative 2x minus, in parentheses, negative 2x plus 10 equals negative 10. It's important that you put it into the other equation, not the same one, because then the variables will cancel, but by accident. When you distribute, you're only distributing negative 1. So negative 2x plus 2x minus 10 equals negative 10. combining like terms, they end up canceling. Your variable cancels, goes away. This is a true statement. -10 does equal -10, so this is inherently any solutions. If the variables canceled and you had two different numbers, then it would be no solution. Questions or not? For 90, you don't have an equation that's solved already, so you have to solve one. If you have a variable that's by itself, solve for that one. So we would get rid of 5y by subtracting 5y to both sides. Then the steps are the same, you're just putting it into x instead of y. So in the other equation, we would put it in for x. So it would look like 6 times -5y minus 1 plus 6y equals -6. And then from there, you could distribute, start combining like terms. We combine our like terms, we get -24y. And then this becomes us solving for y. So add 6 to both sides. And then keep going. Divide both sides by -4. We have a number for y. So if the y cancels, then yes. But in this case, it didn't. That's part of it. We still have to find x. So we're going to take this and put it back in here. And find x. So x equals -5 times 0 minus 1. Or -1. And then once you have your x and your y, put that together as an ordered pair. And that would be your answer. So the reason we didn't get one of those answers before is our variables canceled. So you can have no solution, elimination solution, or a solution. Question so far? $91 is the same as 90. Doesn't have one that's solved, but you can solve this equation for x. Get rid of the 3y by adding it to the other side. So that x equals 3y minus 3 or -3 plus 3y. Then we have an x equals, take that expression and put it in for x of the other equation. So -5 times 3y minus 3 plus 7y equals 23. Distribute, start solving for y. Combine your like terms, you have negative, positive, still negative. Negative y, 8y plus 15 equals 23. Subtract 15 divide both sides by negative. So that when we divide y is negative 1. And then you still have to go back and find x, so put that back in this original. And figure out what x is. We get -3 minus 3 or -6. -6, -1 would be that final answer. You have questions on that or other questions on this page? Go on to the next page. Now we're solving systems by elimination, which is somewhat different than what we were just doing. Of those, which ones do we want to see? Do go over how questions go. Okay. Any others? Okay. We'll start with those. If you have any others, we'll go through those. Goal with elimination, make sure your coefficients, the numbers in front of the variable, are the same. Eliminate them and solve. You also have to make sure they're lined up, so the x's on top of each other, the y's are on top of each other, the constants are on top of each other. So in 92, that is the case. The x's have a similar coefficient, one's -1, one's +1, so we can eliminate our x's. We have to decide, would we add those together or subtract them to get 0? And if you're not sure, you could double check in your calculator. Like say -1 plus 1, that gives me 0. If it didn't, you would choose minus, subtract. So I could add these two equations together. -x plus x, we just found that was 0. 9 plus a -3 would be 9 minus 3, so 6 y. And 11 plus 1 is 12. So then we would be solving for y. You don't really need to do anything with the 0, ignore it. Divide both sides by 6. But that's, again, only half the answer. You still have to find x. So you're going to take that, put it back into one of the equations, does not matter which one, and solve for x. So let's say I chose the bottom one. So then I would solve. X minus 6 equals 1, add 6 to both sides. Still write your final answer as an ordered pair. questions on that one? $95 is similar. The x's and y's and constants all line up, but in this case it's y that has the same coefficient. So we have to again figure out how to eliminate those, either add them or subtract them. I'm going to start with adding and see if that works. -1 plus a -1. That wouldn't work. It didn't become 0, so I have to do the opposite. -1 minus a -1. That did become 0. So we're going to subtract the two equations. And be careful as you're subtracting. Just 5 minus a -7 is really 5 plus 7. Negative y minus negative y is really negative y plus y, so 0. And then 19 minus a -29 is really plus 29. And then you can solve for x. Divide both sides by 12. And after you find x, you have to go back and find y. So put this value into one of these. Does not matter which one. Let's say I choose the first one. And then I start solving for y, multiplying to get 20, moving 20 to get -1, and dividing both sides by -1. If we were eliminating and the variables cancel, you would get either a no solution or infinitely many case. Are there any others on this page you want to see to go over, have questions about? So in this case, we first have to make sure these are lined up. So we can either switch these, just rearrange it. You don't have to put in that 0, but you can if that helps. We could have also made the second one look like the first. Either works. So I'm going to rewrite this underneath here. Look and see if we have a variable with a similar or the same coefficient. In this case we do, the 10s. So we could eliminate those by subtracting 10 minus 10. And we're going to subtract everything. So -7 minus -5 would be the same as -7 plus 5. 12 minus 0 will still be just 12, and those will cancel and become 0. So really, we just have -12y equals 12, 2y equals 12. Divide both sides by negative. Then we could go back and find x. Put this, I would say, in this first one. Then x equals -5 times -6. And then divide both sides by 10. So then our ordered pair would be 3, -6. Others? pages on this page. Go on to the next. So now we're doing systems, but with word problems. Which of these do we want to see do go over? Have questions about? Oh, that's what I thought I saw. Any others? Want to agree? Alright, let's start with those two. If we have any others, we'll do more. When you have your word problems, it's important that you circle, highlight, underline anything that you feel is important. Anything with numbers is going to be important. Whatever the question is asking is also important. So in this case, skipping through a lot of this, we have 13 packages of chocolate chip cookie dough, 6 packages of double chocolate chip cookie dough, total of $138. And then again, 10 packages of chocolate chip, 4 packages of double chocolate, and total of 100. Anytime it gives you 6 numbers, you're going to use all 6 in 2 equations. We're looking for the cost of each type. So before we do anything, we need variables. You can call it C and D, X and Y, whatever 2 variables you want. And use C. And we have to be specific when we define these. We can't just say chocolate chip cookie dough and double chocolate chip cookie dough. We have to say the cost of, price of. So this would be cost of the chocolate chip cookie dough or cost of the double chocolate cookie dough. Then we can set up our 2 equations. Your totals will be what the 2 equations equal, 138 and 100. Your variables are going to go with the numbers that match. So 13 chocolate chip is going to go with C. 6 double chocolate is going to go with D. Because we're looking for totals, we are adding. So then the second equation will be similar. And this one will be 10C plus 4D. Then you have a choice of how you want to solve it, graphing, substitution, elimination. Some work better than others. I would say for this one, use elimination, because substitution, you might end up with fractions. Okay, so if we are using elimination, we have to get one of these to be the same. I think the easiest would be 6 goes into 12, 4 goes into 12, so we can change both of these by multiplying. This entire equation by 2, and this entire equation by 3. So you have 26C plus 12b equals whatever that is. 276. And then 30c plus 12b equals 300. Then we can go on with the eliminating process. We can eliminate these by subtracting. So we have negative 4c equals 24. Negative 24. And then divide both sides by negative 4. Since we were looking for the cost, our label would be dollars, so $6. But that's only one of our answers, the cost of the chocolate chip. We still need to find the cost of the double chocolate. So we would put this back into one of the equations. You have 4, pick one, doesn't matter which one. Let's actually this one. 10 times 6 plus 4, b equals 100. And solve for d. Subtract both sides by 60. And divide both sides by 4. Depending on your word problem, it may make less sense for one thing to be more than the other, so pay attention to that. This one, it doesn't really matter. I guess double chocolate is more of a rarity, so it costs more. Do you have any questions on that one before we do one of them? Same thing in 103. Find important information. So 11 tickets, adult tickets, 8 student tickets, total of 167. We've got $89, 5 adult tickets and 8 student tickets. So we have 6 numbers again. And we're looking for price of an adult ticket and price of a student ticket. So we can define our variables again. You can call them A and S, X and Y, whatever two different variables you want. Since we're looking for the price of each one, that's what we would write here. Price or cost of adult ticket. Price or cost of student ticket. Then you can set up your 2 equations. Totals are 167 and 89. Number of tickets are going to go with the variable. So 11A, 8S, and we're doing total, so we're adding again. And then 5A and 8S. Elimination would be a good one for this again because we have the same coefficient. To eliminate, we could subtract. So we have A, this would become 0, and then whatever that is. 78. And then divide both sides by 6. This one, we're again looking for price, so our label will be dollars. Then we still have to find the S. So you can put that 13 into either equation, doesn't matter. Let's say I put it in the bottom one. And then I could use that to solve for S. $65 plus 8S equals 89. Subtract both sides by 65. And divide both sides by 8. This would again need dollars. This would be a case where usually student tickets cost less than adult tickets in general. So if you've got the other way around, like student tickets costed more, that should tell you something's wrong there. Do we have any questions on that one or any other questions on this page? Go on to the next page. So now we're in inequalities. On this page, are there any we want to see do go over 110? Well, by that item. Any others? Really, if you can do this one, you should be able to do all the others. So first, we would solve this like a regular equation, but it's inequality. So distribute. And I'm going to do all the work down here. So negative 6 minus 7k minus 7 is less than negative 5 minus 15k. Then combine like terms on the same side, so the negative 6 to negative 7. Then you have choices. Move the case to the same side, move the constants to the same side. How you do that is up to you. Let's say I move 15 over. And move 13 over. negative 7 plus 15, positive 8k is less than negative 5 plus 13, also 8, 2, and 5. Wilson, did you have a question or are you sure? If you were dividing by a negative number, you would change the sign, but we're not doing that in this case. So this would be an open circle at 1, going to the left. Do you have any other questions for this page? Go on to the next page. So this should be familiar, as we were just doing compound inequalities, I can't speak, slash when we were doing absolute value inequalities, we did this again. So from this page, which questions do you want to see? Do you go over our questions about? If you don't have any, we're going to go to the next page. So this example is an OR, which means you're going to solve the two inequalities separately. On this side, we would add 7 to both sides. On this side, we would divide both by 5. That would look good. So we have x is less than 3, right? Or in between, x is greater than 9. These would both be open. One at 3, one at 9. The or faces away from each other, so to the left and to the right. Any others on this page? Go on to the next page. And then after we do examples from this page, we will stop for today. So find any questions you have from this page. From this page.
Not for this one, but I have a question for the next one. Okay.
Do you have any questions on the graphing page? Sure. Ask your question.
Okay, not to on the next one. Like the next.
So then this will be the last page. Any other questions from this page? So we need to graph both of these. I would suggest using 2 different writing utensils or colors or something. So for this first one, start at positive 2. Slope is 5 over 2, so we can go up 5 to the right 2, but it runs off the graph. Or down 5 and left 2. Because this is greater than or equal to, this is going to be a solid line, shaded above. So draw the line connecting them.
Here on the question on the final, is it gonna be like is it gonna be like is it gonna tell you like which, like you see how it says like system of inequalities? Is it gonna tell you that?
It'll tell you that part, yes.
Okay,
What you were asking
so-
about.
Oh,
The solid above, no.
Because it tells me like.
Yes, it'll tell you the objective. So if it's shaded above, at your y-intercept, you can draw a small little up and down arrow. Above would be up, so you would shade this area. The y is greater than -3, you have to think about your move ups. It's a y inequality, so this is going to be a horizontal line. So when y is -3, the point there, this is strictly greater than, so it's going to be dashed, but still shaded above. Draw a horizontal line, but make it dashed, so dashed lines. And then shade above. And then if you have two different colors, then you don't need to do this, but let's say you use pencil, you could highlight the overlapping area. Are there any other questions on this page that we want to see, do, go over, have questions about? So then, hold on to this. Next class, we'll continue and start with 5.1.